This is the second part of the skill video for Unit 3, Skills 1 and 2, on identifying functions and their domain and range. So in the last video, we looked specifically at lists of ordered pairs that could also be shown as a mapping or dots or points on an XY axis. Okay, those are called discrete relations or discrete functions because it's just individual points. Okay, now there are also what we call continuous relations or continuous functions. Okay, and we like to look at those on a graph. Okay, now they would be represented by equations, but we're not quite getting into those yet. So let's look at continuous relations. So now instead of individual dots, it's like connected dots. Okay? And the question here is, are they functions, right? How can we tell if it's a function? And then what's the domain and the range, the x's and the y's? Okay? So let's look at this first example. Okay, draw your XY axis. And let's draw this graph. Okay. So this is called a parabola. It's the graph of an equation that has an x squared in it, like y equals x squared. And we want to know, is this graph a function? Okay. Well, now this continuous graph is made up of many, many, many points, right? We could actually kind of darken in some of the points, right, like this. But it has many, 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 right, to fill in that whole parabola. Now, each of those points we could label it with an ordered pair, right, with an x and a y value. Like every single one of these has some x and some y value. So we really do have a set of ordered pairs here. They're just all connected, okay, and continuous. So if this is a function, remember the definition is that every x value can be paired with exactly one y value. Okay? So let's think about this. For this point here, let's think about its x value. Okay, that would be right here on the x-axis. Now, for that x value, it's paired with some y value, which would be right here on the y-axis. Okay? Now, for that x, is it paired with any other y values except that one? I mean, you could check kind of in that vertical line there. Are there any other points there? Well, no, right? This particular x value, maybe it's an x value of 1, is only paired with one y value. So this would be true of actually every point, right? Every single point here. If you go down to the x-axis, okay, and you think, are there any other points along that vertical space, right, where it's paired with a second y value? You'd say no. Okay, here, every x is paired with one y, okay? So this is a function. Okay? Now, when we look at a graph, an easy kind of idea to test if a continuous graph is a function is what we call the vertical line test. Okay? Remember I kept talking about these kind of vertical lines, right? For each of those x values, if you kind of look in the vertical space there, and if there's more than one point along that vertical space at a time, then that graph is not a function, right? It would have an x value paired with more than one y value. So when we talk about the vertical line test, this is a common name for testing whether these graphs are functions or not. Okay? You check to see if a vertical line would touch more than one point at a time. Okay? And if it does, it's not a function, but if it only touches one point at a time, it's a function. Okay? So we could say if a vertical line would touch only one point at a time, the graph is a function. Okay, but you have to look at all points. So think of scanning kind of that vertical line across your graph. If it would only touch one point at a time, the graph is a function. Okay, let's go ahead and look at another example. Here are two additional examples of continuous graphs, and our job is to decide if they are functions. So let's apply that vertical line test to these two. So imagine almost taking your pencil and putting it straight up and down vertically and scanning it across the graph, and if the blue line, okay, if it touches your pencil at more than one spot at a time, it is not a function, right? Because that would mean one x value has multiple y values. So for example, if I had that line scanned here in example 1, notice that it would cross your graph at two spots at once. So that means one x value, whatever this x value here, maybe it's an x value of positive 2, it has two different y values, one that's positive above it and one that's negative below it. So this is not a function. However, in example 2, if you had a vertical line scanned across this graph, there's never a spot where it would touch more than once at a time, right? So like right here, it only touches once, okay, for that x value, and that would be true for any spot along that graph, and so this is a function. Okay, yes. Now, whether a relation is a function or not, we can talk about its domain and range. Okay? So next, let's look at domain. The domain is that group of x values, right? Now here, with a continuous graph, we don't have individual x values that we can list, because in fact there are an infinite number of x values. So we write what's called interval notation. We're going to give the interval of x values. On the first graph, when I look along the x-axis here, I notice that the leftmost x value is here at -2, right? The graph is, it's not graphed any further to the left than -2. And then it covers all x values forever to infinity to the right, right? Because it extends up and to the right and down and to the right in those two directions. But in the x-axis direction, right, it covers every x value starting at -2 and going all the way out to infinity. And so the interval that we write for the domain is the smallest value, x value is -2, and it includes -2, so I use this closed bracket, and then, comma, it goes all the way out to the largest value of infinity, and infinity always has an open bracket, or a rounded bracket around it. Now let's take a look at the range of this graph. The range is the group of y values, the set of y values. So we're looking at the y-axis, meaning up and down. Now this particular graph in blue, it covers all y values, right? Because it goes up forever, up and to the right forever, to infinity, and down and to the right forever to negative infinity. Okay? There's no y value not included in the range of this graph. And so we have two open brackets because we're going from negative infinity to positive infinity. We always put the smaller value on the left, the larger on the right. So let's try that for the second. Okay, we could put D and R. Okay, I want you to think through what would the notation be for the domain and for the range. Maybe pause the video and turn it back on to compare what you think the domain and range are in interval notation for number 2. So check your answers with mine. Okay, for the domain, I'm looking at the x values, and I said it's from negative infinity to positive infinity. Notice along the x-axis here, our graph goes up but to the left forever, that's to negative infinity, and up and to the right forever. So in the x direction, left to right, it goes forever in both directions. And then we always have the open brackets, the curved ones, around the infinity symbols. Then, as we look at the range, I'm looking up and down, right? Well, in the bottom direction, this graph stops here at -3. It does not go any lower, but it does go as low as -3. So that's the lowest value with a closed bracket around it because it does include -3. And then this graph goes up forever, all the way up to positive infinity, so that's the upper part of the interval.